Okay, we're back. This is Stats 189. We're looking at review 4, the review for the last test. And we're all the way on to page 7. Page 7. So we will finish off 7, 8, and 9. Mostly page 7 is going to be done on the computer. You're going to do number 12. You're going to open up Excel. You're going to type in all of the numbers into one column. 6, 22, 35, 10, 8, 12, and 21. And then you're going to put all of the other numbers, the paired, these are matched pairs. 62, 13, 71, 1064, 334, 241, 188, 154, and 125. And so you put that in Excel, highlight it, and then insert a scatter plot. And with the little function, with the little f of x on it. And what that does is it gives you that. And it'll show you it'll say y prime is equal to 0.0681. Oh, wait, nope, not this one. This one is 7.3187x plus 181.66. And it'll tell you R. R is equal to 0.8801. Or wait, no. I don't think it'll tell you R. I think it'll tell you R squared. Gross receipt 5%. So it'll give you R squared. Sorry, it'll give you R squared on the computer. We have to take the square root of that to find R. So it'll tell you 0.7746 on the computer. And then you take the square root of that, and that's your correlation coefficient. So this is the coefficient of determination, but we want R, the correlation coefficient. So that is 0.8801. So this we had to calculate with our calculator, but this was all done with Excel. All right. So then it says, with degrees of freedom, right? We do n. There's 9 pieces of data minus 2. For when you're doing linear regressions, it's x and y, and so you have 2 variables, so it's minus 2 for the degrees of freedom. So degrees of freedom are equal to 9 minus 2, which is 7 degrees of freedom. And then again, on Blackboard or in the appendix of your book, you look up this table where the correlation for 7, 5%, it's got to be better than 0.666. And it is. So R has to be greater than 0.666 for this to be a decent model at the 5% significance level. And so since it is greater than that, 0.88 is greater than 0.67, then we conclude this is a good model. So part A, determine if the significant correlation between the number of releases and gross receipts at the 5% level. It is significant correlation at the 5% level, and then it says determine the best estimate for 200 movies. So basically we're going to use this regression equation for part B, and we're just going to sub in 200. .66, and so you put in a 200 there, you crank that into your calculator, and so y prime is 1645.4. 1645.4. Oh, and that's in millions of dollars. All right. 13 is the same thing. They have calories versus cholesterol on the same food items. And so it's 390 and 43, and 535 and 45, 720 and 80, 350, 430 and 55, 552, and 440 and 60. Again, if you want to see this on Excel, like me actually typing on Excel, go back and look at the chapter 10 notes. For chapter 10, I'm actually in front of a computer, and you can see the drag down menus that I use. All right, instead of me describing it. So it says find the correlation coefficient. Again, you do the same thing. XL kicks out R squared equals 0.5259 with Y prime at 0.0681x plus 22.765. So R is then equal to the square root of that, which is 0.725. Determine if it's good at 5%. 0.754 is it good at 5%? It is not. We needed to beat 0.754, but it's only 0.73. So it was really close, but this isn't a good prediction model. So then it says find the regression equation. So that's already on Excel. That's the Y prime equals 0.0681x plus 22.765. And then it says give a predicted value, but this wouldn't be a good prediction because we just determined it isn't significant at 5%. Maybe at like 10% it is, but at 5% this is not a good prediction. And so that ends up being 63.625 when you sub in 600 calories. All right. Then on the next page, on page 8 of the review, they basically run through the first 4 steps for you. A professor wishes to see if students show a time preference for a stats class. So sample of 4 statistics class shows the enrollment at 1% level. Oof, that's pretty stringent for something like this. Do the students show a time preference? Use the critical value method. So this would be a chi-square, a goodness of fit test. So if they were all the same, we would add them up and divide by how many there are. And each one should have answered that way. So it would be observed minus expected squared divided by expected. You'd find the chi-square statistic. But look, they already have the null and the alternative given. Students show no preference for class time. Students show a preference for class time. So that's either the same or different. They have the critical value for us already, 11.345. And they've already calculated the chi-square. The chi-square is 3.215. So all we have to do is make the determination. Should we reject the null or fail to reject the null? Well, it had to beat 11.345, but it's only 3.215. So it didn't meet the criteria. It's in the unshaded area, so we failed to reject the null. Students show no preference for class time according to this data. All right? So that's the reason I put it on the review like this, where you didn't actually have to find it, the chi-square statistic, and set it all up, is because on the test, it's going to be given like this, and you're going to just have to make the determination, you know, either reject the null or fail to reject the null. All right? And then same thing for the F distribution. The F distribution, that's the one that you had to put into the computer and run an ANOVA. That's already going to be given. So like 15, they have the setup, they have the data, but you don't have to use that because the hypothesis is given, the critical value is given, and the F statistic is given. And so you just have to basically look at the critical value and the F statistic and determine the critical value is 3.52, F statistic is 7.71. Therefore, we reject the null, and at least one of the means is different. So we reject the null at the 5% significance level. So it's already going to have the workup for you. You're just going to have to look at the 2 statistics. Now, why did I set up those 2 problems like that? When you're working the chi-square goodness of fit and you're working F distributions, usually you're going to use some kind of statistics software, but you're still going to have to make the determination, either based on the p-value. I know the Alex homework was really heavy into the p-value, or like the F statistic or chi-square statistic. And that's basically what our hypothesis testing, because we're using charts. I wasn't real heavy into the p-values. If you're using software, p-values have become a little more popular in the world of statistics. So that's what the test looks like. Study, study, study. Finish strong.